Hi everyone, welcome back to our channel. In this session, we are going to know about matter and types of matter. This topic is from atomic structure IIT topic. Matter. What is matter? Do you know what is matter? The thing which occupies space and mass is known as matter. The thing which is having mass and occupies space is known as matter. For example, the paper. The paper is the one of the matter, and speds. This is also matter. It occupies space and mass. It having mass. And a book. This is also having specific mass and it occupies space. And benches, racks, and a board and a pen. Even though it is a matter. The thing which occupies space and mass is known as matter. The matter is mainly divided into physical classification and chemical classification. In physical classification is the matter can be divided physically. He is known as physically classification. In physical classification, the matter is mainly solid, gases, liquids, plasma, and Bose-Einstein condenser. Physical classification is mainly solid, liquid, gas, and plasma, Bose-Einstein condensation. And chemical classification, it is divided into two types: pure substances and mixtures. Pure substances and mixtures. The mixture is maybe homogeneous mixture and heterogeneous mixture. The mixture is pure homogeneous mixture and heterogeneous mixture. And also pure substance, it is a chemical classification. It is divided into two types: element and compound. What is that? Element. The pure substance can be divided into two types. One is the element and second one is the compound. The element maybe again it can be divided into four types: metals, non-metals, metalloid, noble gases. Metals, non-metals, metalloid, and noble gases. Once again I repeated, the matter. What is matter? The thing which having mass and occupies space is called matter. The matter divided into two types. It can be divided into physically and chemically. The physical means solid, liquid, and gas, plasma, Bose-Einstein condensation. They are asking like this: what is the fourth state of matter? What is the fourth state of matter? The answer is plasma. What is the fifth state of matter? Bose-Einstein condensation. Okay students, have you understood? The physical classification mainly solid, liquid, and gas, plasma, Bose-Einstein condensation. They are asking question is like this: what is the fourth state of physical classification? The physical classification, the fourth state of physical classification is plasma, and the fifth state of physical matter is Bose-Einstein condensation. Have you got it? Okay. Next, chemical classification. This chemical classification of matter, again it can be divided into pure substance and mixtures. This mixture is divided into two types: homogeneous mixture and heterogeneous mixture. Homo means same, that is the same phases, same mixture, and heterogeneous mixture, it is a different. Hetero means different. And pure substances, again it can be divided into element further classified into metals, non-metals, metalloid, and noble gases. And second one is the second pure substance is the compound. Okay, what is mean by pure substance? The pure substance means the substance which contains same kind of particles. Same kind of particles is called as pure substance. The substance which consists of same kind of particles is called as pure substance. For example, generally we know gold containing pure substance of gold or molecules. It can be made with only gold particles, and that means the gold is not react with water or atmosphere. There is not reactivity. Gold is the slowest reactivity. The slowest reactivity metal is gold, because we wear ornaments, gold ornaments. It can be not changed. It can change to so many years. So the reactivity is less gold molecules. So the same kind of substances of particle is called a pure substance. And also NaCl, CO2, H2O, and Cl2 gas, sodium metal. These are the pure substances. Okay students, have you got it? And another one, the pure substance, it can be furtherly divided into two types. That is the element. First one is the element. The element means the substance which cannot be broken into further any other substances is known as element. Already I told you element gold. It can be divided. It can be broken. It can be broken. That means, for example, RM gold biscuit. With I take gold biscuit, it can be broken, and I can cut it. I can cut it small pieces, and again small pieces, again small pieces. It can be further divided into any other substance. So that is called it as element. Same thing like a sodium metal. Sodium metal consists of sodium metals only. It can be divided into, that means any broken, it cannot be broken further into any other substance. So that is, we call it a name as element. Okay, what is an element? The substance which cannot be further divided any other substance is called it as element. And next one is the symbol. Symbol. What is symbol? The symbol can be the shorthand representation. The shorthand representation of an element is known as symbol. Shorthand representation. For example, I take hydrogen. The hydrogen can be I represented as hydrogen H. And helium can be I take shorthandly helium. Helium He is known as helium. And same that is it can be divided into further letters, Latin names like this. Okay. Next, what is symbol? The shorthand representation of an element is known as symbol. And single letter symbols is the first letter being the first letter, that means the hydrogen. Hydrogen can be represented as H. Boron can be represented as B. That means the hydrogen symbol is H. Boron symbol is B. Carbon symbol is C. And oxygen symbol is O. Fluorine symbol is F. Nitrogen symbol is N. These are the single letter symbol. And we have a double letter symbols also. What are they? Are platinum, helium, neon, argon, aluminium, chlorine, like this. In this double letter symbol, the first letter being capital and second letter being, that is the second letter is, we should write a small letters. Okay, the platinum symbol PT, in the PT, the P is the capital letter and T is the small letter. Okay, got it? Helium, again helium, the hydrogen is the capital letter, E is the small letter. The helium symbol is He. And neon symbol is Ne. Argon symbol is Ar. Aluminium symbol is Al. Chlorine symbol is Cl. Bromine symbol is Br. These are the double letter symbols. So we have so many double letter symbols are there. These are the, I will explain the double letter symbols again. Okay. Next, the letter is the Latin names. The symbol starts with the Latin names. Why we are called it as Latin names? For example, sodium. The sodium came from Latin word natrium. Sodium came from natrium. The question is like this. The symbol of the element natrium is. The element natrium is, they gave options like sodium, potassium, that means the chlorine, these are the sodium came from natrium. So the sodium natrium, in this first two words Na. So sodium is the chemical symbol is Na, and potassium symbol, the potassium came from Latin word, that is kalium. The kalium symbol is K. So the potassium, the K is came from kalium, that is we call it as potassium. And mercury, this is came from Latin word hydrogerum. What is that? Hydrogerum. Mercury came from hydrogerum, so we can represent it as a Hg. Already I told you the first letter is capital and second letter is small letter. Okay, this is a mercury symbol Hg. And lead came from Latin word plumbum, the symbol is Pb. And copper came from Latin word cuprum, the symbol is Cu. And iron, the symbol, the Latin word is ferrum, it is Fe. The iron, that is the iron symbol is Fe. And tin, it is came from stannum, it is represented by the symbol Sn. Okay, the sodium Na, potassium K, mercury Hg, lead Pb, copper Cu, iron Fe, tin Sn. Because the questions are asking like this. The symbol of mercury is Hg. The symbol of lead is Pb. The symbol of copper is Cu. And also they are asking like this. The sodium came from Latin word, that is natrium, gallium, like this. Okay. Have you understood? These are the elements. These are came from Latin names. That's why we called it as the symbol of Latin word. Okay. Next, it can be classification of elements. It can be metals, non-metals. Okay. Metals, non-metal. Already we know metals. For example, you think aluminium, iron, and aurum, copper, these are the metals. Think, let us assume solids is except hydrogen and gallium. The remaining all these are elements. For example, metals 1A and 2A group elements in periodic table. 1A, 2A group elements are, we called it as metals. The 1A group element is called it as alkali metals and 2A group element is called it as alkaline earth metal. Why we are called it as metals? That means the metals are high melting points and boiling points. These are the shining nature and sonorous, lustrous nature. Lustrous means the shining surface, and sonorous means the making sounds, and malleable, it can be converted into thin sheets to prepare vessels in kitchen. Ductile, drawn into long wires. These long wires are can be used into the electricity. Okay, these are the metals. Metals having the so many properties are there. Metals may be, for example, except hydrogen, that is except mercury and gallium. These only two metals are the liquid metals. They ask me like this: the liquid metal is, okay, they are that is the potassium. They gave you options like this: sodium, potassium, and cesium, and Hg. In this, Hg is the liquid metal. Remaining all these metal Hg and except Hg and gallium, remaining all these are solids in nature. We are available in solid form of nature. Okay, and next one is in these metals having high melting points and boiling points. They have ductile nature, malleable nature, and sonorous nature, lustrous nature. And we go into see non-metals. Non-metals having the in this except bromine. It is a brittle solid. Bromine is the liquid non-metal. Bromine is a liquid non-metal. Most of the non-metals are gases. They are available in gaseous form. Okay, except bromium, except bromium, remaining all these are gases. Okay, it having low melting points and boiling points. For example, in case diamond, except diamond only, remaining all non-metals having low melting points and boiling points. And these are non-ductility nature, non-malleable nature, and non-sonorous nature, and non-lustrous nature. Except I2, remaining all these non-metals are non-lustrous. That means they are asking like this. The question they are asking like this: the low melting points and boiling points. The metals they gave options like this: metals, non-metals, metalloids, and all of this. Okay, which one is correct answer? Low melting point and boiling point. Non-metals have the low melting point and boiling point, except diamond. All the non-metals having the low melting point and boiling point. They gave options like this. The metals have the metals or non-metals. Metalloids are these kind which having shining nature. Metals having shiny nature. Have you understood? Okay, and metals having sonorous nature. For example, in going to church or going to any kind of devotional places, they hang a bell. For example, we rang a bell. They making sound like the sonorous. That means a ting like this. Okay. Have you understood? These are the properties of metals and non-metals. And remaining metals are good conductors of heat and electricity, and non-metals are bad conductors of heat and electricity. In this, iron, Fe, copper, Cu, gold, aurum, silver, Ag. These are the metals. These are the good conductors of heat and electricity. They passing through the heat and they passing through the electricity. Okay. For example, the copper wires, iron wires, and these are the silver wires we are using. We are using electricity department. These are the metals. Inside the cable, we can identify the some metal wires are there drawn into thin wires like this. These are the metals. Okay, iron, copper, and gold and silver. These are the good conductors of heat and electricity. And the remaining non-metals are the bad conductor of heat and electricity, except graphite, because in graphite having the free electrons, so it is acts as a good conductor. Except graphite, remaining all these non-metals are bad conductors of heat and electricity. For example, chlorine gas, bromine gas, iodine gas, and oxygen gas, nitrogen gases. Okay, these are bad conductors of heat and electricity, because these are non-metals are except bromine, remaining all these are gaseous elements, non-metals. Okay, have you understood metals and non-metals differences? And next one is the metalloid. What is metalloid? The metalloid is the same element having metal properties as well as non-metal properties. For example, boron and silicon, germanium, arsenic, antimony, tellurium, polonium. Boron symbol is B and silicon symbol is SA, germanium symbol is G, arsenic symbol is AS, antimony symbol is SB, SB means the strontium, and tellurium symbol is TE, polonium symbol is PO. These are the 7 metalloids in the periodic table. These elements having exhibits both metal properties and non-metal properties are exhibits. So we are called it as metalloids. Metalloid. These are the metalloid. And next one is the noble gases. Okay, these are the heroes of the periodic table. Okay. What are noble gases? We know the aethia group elements or zero group elements, we call it as noble gases. Noble gases having so many names are there because of their obtaining nature, that they are not a reactor, so that we are called it as inert gases. They're having these available from earth crust, so we are called it as noble gases. And these are the ideal of the gases, that's why we are called it as ideal gases. And their valency is 0, so we are called it as zero group elements. Noble gases and zero group elements, and third one is inert gases, and fourth one is ideal gases. These are the names of the noble gases. Okay, these are rarely available in nature. These are monoatomic gases. Mono means what? Single. These are the single available gases. These are the rarely available in mixture, so these are called it as noble gases. Their valency is 0. These are more stable, so we are called it as inert gases and noble gases. They have fully filled configuration. For example, helium. They contain helium containing 1s2 electrons in a outermost shell, and argon containing neon and 3s2 3p6. That means they having contained the they are a fully filled configuration. There are no unpaired of electrons in their outermost shell. Their valency is 0. That's why we are called it as the hero of the gases. For example, now helium, we having seven noble gases are there in the periodic table. Helium, neon, argon, krypton, xenon, and radon. Helium, neon, argon, krypton, xenon, radon. This having NS2 NP6 configuration. What is the configuration of? They are asking like this. What is the configuration of noble gases? The noble gases configuration is NS2 NP6 configuration. They are having zero unpaired electrons. These are fully filled electrons. Okay, configuration. So these are the noble gases. They are available from earth crust. Okay, have you understood? Okay, next topic is formation of compound. What is compound? How it is formed as a compound? The number of atoms, various elements present in it. Okay, the compound having the number of atoms or various elements present in it. For example, 1 CO. In CO, carbon monoxide, we call it as carbon monoxide. In CO, 1 carbon atom there, 1 oxygen atom there. 1 carbon atom there, 1 oxygen atom there. That is the one is the 1 molecule of carbon. 1 molecule of CO is containing 1 carbon atom and 1 oxygen atom. In Na2CO3, the one molecule of, in case there is no number is there, we kept one is there. Okay, one molecule of Na2CO3 containing two times of sodium atoms, one of carbon atom, three times of oxygen atom, and NaCl, one of sodium atom and one atom of chlorine atom present in it. In H2SO4, two hydrogens are there, one sulfur atom is there, four oxygen atom there. Okay, these are the formation of compounds. And next one, the formation of important common compounds are hydrochloric acid. We call the name as HCl, represented like this. Hydrochloric acid is represented HCl, and sulfuric acid we called it as H2SO4, and sulfurous acid H2SO3, nitric acid HNO3, nitrous acid HNO2, and carbonic acid H2CO3, and sodium sulfite and Na2SO4, and sodium zinc sulfate ZnSO4. These are the important common compounds. And next one, and also cuprous chloride Cu2Cl2, cupric chloride CuCl2, plumbous chloride PbCl2, plumbic chloride PbCl4. Okay, these are the compounds. And we having so many gaseous compounds in our daily life. That is a carbon dioxide, CO2, sulfur dioxide represented like this, SO2, sulfur dioxide represented like this, COSO3, nitrogen dioxide represented like this, NO2, nitrous oxide represented like this, N2O. N2O we called it as laughing gas. N2O is a laughing gas. The gas is passing through human beings. They are automatically laughing. Okay. Next, hydrochloric acid vapor HCl, stream is the H2O. Okay, and next one is the metal oxides. In metal oxides, sodium oxide Na2O, calcium oxide CaO, magnesium oxide MgO, aluminum oxide Al2O3, iron oxide Fu2O3, and metal sulfide zinc sulfide, that is the ZnS. Ferrous sulfide Fu2, yes. Sodium sulfide Na2, yes. Calcium sulfide Ca2, yes. Okay, these are the metal sulfides. These are the compounds. Okay, one or two, that is for example, two molecules of CO2, that these two can be represented as prefix and these two can be represented as suffix. Okay, in case in these two carbon atoms are there and two carbon atoms are there and oxygen atoms 2 into 2, 4 oxygen atoms are there. Okay, have you got? The questions are like this. In Na2CO3, they are containing how many molecules? 5, 6. They gave you options like this: 5, 6, 3, like this. In this, we calculated 2 sodium atoms, 1 carbon atom, and 3 oxygen atom. Total, how many atoms are present on it? 6. This is the in Na2CO3, 6 atoms are present on it. And they are asking like this. Now one more important is the AlNO3 trace. In this, how many aluminum molecules are present on it? How many Na2 present on it? They are okay, 1 aluminum atom and 3 nitrogen atoms and how many? 3 into 3 oxygen atoms. So total, how many oxygen atoms are there? 6 oxygen atoms there. And the one more question is like this: Na2CO3. How many atoms are present on it? To 1 sodium atom, 1 hydrogen atom, 1 carbon atom, and 3 oxygen atom. Total 6 atoms are present on it. 1 molecule of NaHCO3 containing 1 sodium atom, 1 hydrogen atom, 1 carbon atom, and 3 oxygen atoms. Total 6 atoms are present on it. Have you understood? Okay. Next topic is valency. What is valency? The valency is how to calculate valency. Okay. In this topic, we can understand this topic is the valency. The combining capacity of an element is known as valency. What is the definition of valency? Is the combining capacity of an element is the valency. In this metals valency, metals containing valency and non-metals having the their valency, and non-metals having the 8 minus valence electrons. 8 minus valence electrons is known as valency. They gave. Now in this 1A and 2A group elements, 1A and 2A group elements, this having the valency is 1 electron, their oxidation state is +1. And 2A group elements containing 2 valence electrons, its oxidation number is 2. And 3A, 4A and up to 7A, it containing 3A group elements containing 3 electrons, 4th A group elements containing 4 electrons, 5th A group elements containing 5 electrons, 6th A group elements containing 6 electrons, and 7th A group elements containing 7 electrons, and 8th group elements containing 8 valence electrons. These are the valency. What is valency? For example, sodium. In sodium atom, their atomic number Z equal to 11. Z equal to 11. The atomic number of sodium is 11. The atomic number of sodium is 11. The Z is the atomic number, the symbol of atomic number. Their configuration I wrote like this: 1s2, 2s2, 2p6, 3s2. I am following Hund's rule, Pauli's rule, and Aufbau principle. I wrote like this: 1s2, 2s2, 2p6, and 3s. Here, in a K shell containing 2 electrons, L shell containing 8 electrons, M shell containing 1 electron. In the K shell and L shell, now K shell capacity is 2 electrons only, L shell capacity is 8 electrons only, and M shell capacity also 8 electrons in this 3p0 containing 8 electrons, but it can occupy only single electron. So this single electron can only participate in the bond formation. This is known as the outermost shell containing 1 electron, that is known as valency electron. So sodium containing 1 valence electron. Have you got it? Have you understood? And carbon containing 4 valence electron. How to calculate it? Carbon is a non-metal. Non-metals having the valency calculated like this: 8 minus valence electron. 8 minus valence electrons. That is the carbon atomic number is 6. So I wrote configuration like this: 1s2, 2s2, 2p2. In outermost shell, K shell, that is a L shell containing 4 electrons. The L shell containing 4 electrons. So the non-metal having the formula 8 minus valence electrons. 8 minus 4 equal to 4. The 4 is a tetravalency. So the 4 electrons contain, the 4 electrons participates bond formation. Okay. And next one, nitrogen. Nitrogen atomic number is 7. 1s2, 2s2, 2p3. Nitrogen is the non-metal also. Non-metal formula, the valency formula is 8 minus valence number of valence electrons. In this nitrogen, K shell containing 2 electrons, L shell containing 5 electrons. So these are L shell is the outermost electron. 2s 2p shells, 2s 2p subshells or the outermost shell. So that is the L shell. So L shell containing 5 electrons only. So these 5 electrons, 8 minus 5 equal to 3. Nitrogen valency is 3. That is the nitrogen having 3 valency. And oxygen, I see oxygen atomic number 8. There are configuration I wrote like this: 1s2, 2s2, 2p4. Oxygen is the non-metal. So their valency can be calculated by 8 minus valence electrons. 8 minus 6. 6 is the number of valence electrons in the outermost shell. Okay, 8 minus 6 equal to 2. Oxygen valency is 2. And fluorine. Next one is fluorine. The fluorine is the 1s2, 2s2, 2p5. The configuration is like this. In this outermost shell is 2s2, 2p6. 2s to 2p. This is the 1s is the K shell, 2s, 2p are the L shell. L shell containing 7 electrons only. So 8 minus 7 equal to 1. Fluorine valency is 1. Except fluorine, chlorine, bromine, iodine, and astatine. Astatine, bromine, iodine, chlorine, fluorine, and astatine. These having the valency 1. Okay. This having the valency 1 in their outermost shell. They are asking questions like this: what is valency? The combining capacity of an element is called as valency. And asking questions like this: the potassium valency is 1. So it always losing 1 electrons. It always readily to lose 1 electron. Sodium, potassium, and sodium, potassium, and 1A group elements, that is sodium, potassium. That is the 1A group in a periodic table is hydrogen, lithium, sodium, potassium. That is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. These are the 1A group elements. These are always ready to lose one electron in their outermost shell. They are ready to lose 1 electron in their outermost shell. They are ready to lose ready to lose 1 electrons. So we are called it as highly reactive metals, because it is ready to lose 1 electron to form a ready to lose 1 electron to attain octet configuration. Okay, what are they are? Lithium, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are the 1A group elements. These are ready to lose 1 electron in outermost shell to get octet configuration. That's why we are called it as the highly reactive metals. The highly reactive metals in a periodic table is 1A group element. Have you understood? And next one is the valency of noble gases. The valency of noble gases. Valency of noble gases is 0. Valency of noble gases is 0. And non-metals having the valency, how to calculate it? 8 minus valency electrons in a outermost shell. And it can be valency to attain, that means the lose or gain. In case of losing, they attain cation configuration, and gaining to attain negative ion. That is in case lose to form a cation and gain to form a anion. Have you got it? Okay. Next one is the Al2O3. In Al2O3, that is the example like this. In Al2O3, the aluminum valency is 3 and sulfur valency is 2. Zn plus 2, Na plus, Cl plus 2. These are having the Cu plus 2 having the variable oxidation states like 1 or 2 or 3. Okay, have you understood? This is the valency. Okay, and one more example is SF6. In SF6, fluorine having the valency is 1 and 6 valency is 6. 6 valency is 6 in SF6. Have you understood topic valency? What is valency? The valency is the combining capacity of an element is known as valency.